Dear students, we come up with this video in a very interesting problem. So consider a set of a equal to r square, x square equal to a into a plus 1, a plus 2 as real root, as a single real root. So the number of connected components of a. Okay, so a equal to set a equal to a belongs to r, and x square equal to a plus 1 and a plus 2. So one real root. So the condition of the real root is if x square equal to I, then I less than 0. So you have the real root. So here a equal to this thing. So a belongs to r. A plus 1, a plus 2 greater than 0. So a x belongs to r given x plus 1 x plus 2 greater than equal to 0. So roots of the function are 0, minus 1 and minus 2. The interval of the function, intervals are, if we just take it, minus infinity to minus 2, minus 2 to 0, minus 1, minus 1 to 0, 0 to plus infinity. So here x is negative, less than 0, positive, greater than 0, less than 0, greater than 0. So therefore the set of the real roots lie between minus 2 to minus 1 union 0 to infinity in these two zones. So the number of connected components of a is 2. So these are called, like, you go for the solution and you find the number of cases. So if the third one is also there, so number of connected components are 3. So this one is a very classic question which will help you to solve some parallel questions like this as well. Thank you.